Namaste children. So we are discussing the first chapter, number systems. So today we are going to discuss identities related to square roots and their applications, and the main concept of today's class is rationalization. Rationalizing the denominator, rationalizing the numerator. Clear? Yes. What are the identities related to square roots? So the square roots and cube roots we have studied in class 8. Class 8, square roots and cube roots. The symbol, what we call this symbol? Yes, the symbol is called square root, and especially we call this as radical sign. Radical sign. What is this called? It is radical sign. So now square root of the numbers we use real numbers. Let here a and b are two positive real numbers. For all positive real numbers a and b, square root of a into b, square root of a into b is equals to square root of a into square root of b, root a into root b. Simply it is root a into root b, or root a into root b is equals to root ab, root ab, a into b. Root a into root b is equals to root a into b. Both LHS is equal to RHS we can apply, RHS to LHS also we can apply. Similarly, square root of a by b is equals to square root of a divided by square root of b, or square root of a divided by square root of b is equals to square root of a by b. Third identity, square root of a plus square root of b into square root of a minus square root of b. If you observe clearly, this is our third algebraic identity. A plus b into a minus b is equals to a square minus b square. The same is also applicable for square roots. Root a plus root b is equals to into root a minus root b. Apply a minus b whole a square minus b square form. Root a whole square into root b whole square. Squares and square root will be cancelled. We will get a minus b. Now a plus root b into a minus root b. Again this is also a plus b into a minus b is equal to a square minus b square. So a square minus b square in the sense square root of b whole square. Square and square root will be cancelled. We get b. A square minus b. Next, the fourth algebraic identity we are using here also. Square root of a plus square root of b into square root of c plus square root of d is equals to, that is square root of a into c, that is ac, square root of a into d, that is square root of ad. Means a is multiplied with c and d, then b is multiplied with c and d, that is square root of b into c, bc, square root of b into d, that is bd. Then root a plus root b whole square, it is a plus b whole square form, a square plus 2ab plus b square. A square means here a is root a. Root a whole square is equals to a plus 2 into root a into root b, it is root ab plus root b whole square is equals to b. So these identities we use, not only this a minus b whole square form also we use in solving some of the problems related to these square root sums with these identities. Is it clear, the identities? You have to remember and you should apply them in solving the problems. Now, example number 16. Simplify the following expressions. Simplify the following expressions. Under that, the first one it is first question. 5 plus root 7 into 2 plus root 5. 5 plus root 7 into 2 plus root 5. That is, we can apply, that is root 5. 5 is multiplied with 2. 5 is multiplied by root 5. We have the identities and they use that identities and we can simplify this. So 5 into 2 plus 5 into root 5 plus again with root 7. That is, we are using here distributive property. With 5 you multiply both 2 and root 5, and again with root 7 you multiply both root and 2 and root 5. So root 7 is multiplied with 2 plus root 7 into root 5 plus root 7 into root root 7 into root 5. So what we get? Yes, 5 into 2 it is 10 plus 5 into root 5 it is 5 root 5 only plus root 2 into 7 that is 2 into 1 2 root 7 2 root 7 plus root 7 into root 5 that is root a into root b is root a into b 7 into 5 it is 35 root 35 root 35 like this we can multiply 5 into 2 it is 10 5 into root 5 it is 5 root 5 root 7 into 2 it is 2 root 7 root 7 into root 5 it is root 7 into 5 root 35. Next the second question we have 5 plus root 5 into 5 minus root 5. Yes, this is in the form of a plus root b plus into a minus root b, that is a plus b into a minus b is equals to a square minus b square 5 square. A is equals to it is 5 square minus b square means root 5 whole square. So square and square root are cancelled both. Now 5 square is equals to 25 minus 5. 25 minus 5 is equals to 20. Like this we can simplify using the identities. First square roots also. Now third question. Root 3 plus root 7 whole square. Root 3 plus root 7 whole square. A plus b whole square is equals to a square plus 2ab plus b square. Root a plus root b whole square is equals to a square a plus 2 root ab plus b. Or apply a plus b whole square formula. Root 3 whole square, yes, plus 2 into root 2 into a into b. A is root 3 into b is root 7. Root 3 into root 7 plus b square. Here b is root 7, that is root 7 whole square. Now we simplify. Square and square root are cancelled, therefore you get 3 plus 2 root 3 into root 7 root a into root b it is root 21, therefore it is 2 root 21 plus root 7 whole square. Square and square root are cancelled, get 7. So now we can add these two numbers. They are rational numbers. You should not add 3 and 2 because 2 is the coefficient of root 21 which is a irrational number. You should not add these two, but you can add 3 and 7. 3 plus 7 it is 10 plus 2 root 21. 10 plus 2 root 21. Next, the fourth question here we have root 11 minus root 7 into root 11 plus root 7. So again a minus b into a plus b, a square minus b square, that is equals to root 11 whole square minus b square means root 7 whole square. Square and square root are gets cancelled. Square and square root are get cancelled. Now what is left? 11 minus 7, that is equals to 4. So like this we can simplify this kind of expressions by using the algebraic identities. Those identities are also applicable for the, what I mean to say, it is square roots also under for real numbers. Rationalizing the denominator, that is rationalization. What is rationalization? The process of converting a rational number to an irrational number is known as rationalization. Here what is rationalizing the denominator? So we will find some real numbers whose denominators are irrational numbers, or the denominators are the numbers in the form of what square root under some numbers, under square root some numbers will be there. Such numbers, how can we convert them to rational number? That process is known as rationalizing the denominator. Not only denominators, we also can convert the numerators also, rationalizing the numerator, that concept also. That is also converting numerator to the rational number is known as rationalizing the numerator. So how it is done? By using that identities we can use. So in identities we use and we will convert them to the that rationalization. or we use a term called factor, rationalizing factor. We use a term called rationalizing factor. What is rationalizing factor? By multiplying a number, by multiplying an irrational number with some number, the product is a rational number. Then the number which is used to multiply is known as conjugate or rationalizing factor. Like what we have studied, this reciprocal. So here each number is the conjugate or rationalizing factor of the other number. So here we are using rationalizing factor. How do we get rationalizing factor? While we are discussing these examples, we will discuss. That is by interchanging the sign. If it contains two terms, plus as minus and minus as plus, we get the factors. That factor is a rationalizing factor. Now here we will discuss a few examples. Rationalize the denominator of 1 over root 2. 1 over root 2 here. 1 by root 2. Here what is the denominator? Root 2, which is an irrational number. So to rationalize this, what we have to do? Yes, we need to multiply some number. If I multiply with root 3 or if I multiply with 2 into root 2, it is again that we have said a rational number and an irrational number. Their product is always an irrational number. So with what we have to multiply? Yes, we have to multiply with some irrational numbers. If I multiply this with root 2 into root 2 will get what? Root 2 whole square, which is 2 will get. 2 is a rational number. So when we are multiplying the denominator, simultaneously we have to multiply the numerator also with root 2. Now 1 into root 2 it is root 2 divided by root 2 into root 2 it is root 2 whole square. Square and square root are cancelled, or root 2 into root 2, root a into root b is equals to root a into b, that is 2 into 2 it is 4. Root 4 we get, root 4 is equals to again it is 2. So you can do any way. That is root 2 divided by 2. So now the denominator what is 2 is a rational number. Our question, root 2 which is an irrational number. We have converted this irrational number to the rational number form 2. Clear? This method is known as rationalizing the denominator. Here root 2 is called rationalizing factor of root 2. Root 2 is called rationalizing factor of root 2. Now example 19. Rationalize the denominator of 5 by root 3 minus root 5. So we have to multiply this using the identities we can use or using the rationalizing factor. So find the rationalizing factor of the denominator, or F stands for rationalizing factor of the denominator root 3 minus root 5, which is equals to root 3 plus root 5. Just to change this sign, plus as minus. Minus if we find, it will become plus. Plus is there, minus is there, plus. Now multiply the given number, both numerator and denominator, with the rationalizing factor of the numerator. So denominator. So what is the denominator is root 3 minus root 5. Its rationalizing factor is root 3 plus root 5. That is root 3 plus root 5 into root 3 plus root 5. Both are to be multiplied, numerator and denominator. So here we are multiplying with 5. 5 into 1. Here root 3 is 1 root 3. Multiply the coefficients. 5 into 1. 5 root 3. Plus into plus. 5 into 1. 5 root 5. 5 root 5 divided by. Now you see this. Root 3 minus root 5 into root 3 plus root 5. It is in the form of root a minus b into a plus b is equals to a square minus b square, that is root 3 whole square minus root 5 whole square. A square minus b square, where a is root 3, b is root 5 it is. Now square and square root are cancelled, square and square root are cancelled. Now what we get, that is 5 root 3 plus 5 root 5 divided by, so what is the, it is 3 minus 5. 3 minus 5 is equals to what? Minus 2. Minus 2 divided by, that is numerator what we have? 5 root 3 plus 5 root 5. 5 root 3 plus 5 root 5. Now this by using the bringing this minus sign to the above, what we can write as minus 1 by 2 into 5 root 3 plus 5 root 5. We get 5 root 3 plus 5 root 5. See here the denominator what we got 2 we got. So even then we can simplify that. Finally what we get it as what minus 5 into root 3 plus root 3 minus 5 into root 3 minus root 5 by 2. So what is the denominator finally which we got here is 2, which is a rational number. So we have rationalized the denominator. The denominator change into the rational form. Is it clear, children? So when we take here minus 5 common, minus 5 into root 3. So here plus is there. Here we have plus minus 5 we take common. Then what we get is plus. So minus 5 whole to the power, that is into root 3 plus root 5 by 2. If you multiply, we get the same result. Minus 5 root 3 minus 5 root 5 by 2. Like this we can rationalize the denominators. Still we discuss few more questions of the same kind. Yes, now we will discuss exercise number 1.5. The fifth bit, rationalize the denominators of the following. So here, second one, 1 square divided by square root of 7 divided by square root of 7 minus root 6, square root of 6. The fourth question is 1 divided by root 7 minus 2. So here the denominators we have to rationalize. The second question it is 1 divided by root 7 minus root 6. Now the rationalizing factor of root 7 minus root 6 is equals to what it is? Yes, root 7 plus root 6. Multiply the given number, that is 1 by square root of root 7 plus root 6 with what? The rationalizing factor it is root 7 plus root 6, both numerator and denominator. Like this you multiply. So here it is root 7 minus root 6. Now when you multiply with 1, we get the same number. 1 into root 7, it is root 7 plus 1 into root 6, it is root 6 divided by. Now root 7 minus root 6 into root 7 plus root 6. A minus b into a plus b is equals to a square minus b square. That is root 7 whole square minus root 6 whole square. We will get square and square root are cancelled, square and square root are cancelled. So now what we get by simplifying this, root 7 plus root 6 divided by, so what is left, it is 7 minus 6. That is equals to square root of 7 plus square root of 6 divided by 7 minus 6, it is 1. So when we divide with 1, what we get? The same number, root 7 plus root 6. Root 7 plus root 6 we get as the answer. So now here the second bit, that is the fourth bit, here we are going to discuss now. Fourth bit, 1 divided by square root of 7 minus 2. Here the rationalizing factor or f of root 7 minus root 2 is equals to, so root 7 minus 2, not root 2, is equals to root 7 plus 2. Root 7 plus 2. So now multiply both numerator and denominator of the given number with root 7 plus 2. Root 7 plus 2. Yes, what we get? 1 into root 7 plus 2, it is root 7 plus 2 itself divided by root 7 minus 2 into root 7 plus 2. A minus b into a plus b, that is equals to a square minus b square, which is root 7 whole square, root 7 whole square minus b square means 2 square. So now by simplifying this, what we get? That is equals to root 7 plus 2 divided by square and square root are cancelled. That is 7 minus 2 square is equals to 4. that is equals to root 7 plus 2 divided by 7 minus 4 is 3. So now the denominator is 3 we got. Like this we can rationalize the denominators of the given numbers. Is it clear, children, how to rationalize the denominators? Yes, we will discuss now one more example. Simplify. First bit, 1 divided by square root of 7 minus square root of 3 plus 1 divided by square root of 7 plus root 3. B bit, root 5 plus 2 divided by root 3 minus root 2 minus root 5 minus root 2 divided by root 3 plus root 2. Here two terms are there. How to simplify them? Then first one divided by root 7 minus root 3 plus 1 divided by root 7 plus root 3. So simplify them individually. Rationalize the denominators. What it is, denominators individually in each term. Then what it is, simplify them will get. Now RF of rationalizing factor of first denominator is root 7 minus root 3 is equals to root 7 plus root 3. Similarly, rationalizing factor of root 7 plus root 3 is equals to root 7 minus root 3. Now you simplify faster individually. 1 divided by root 7 minus root 3 is multiplied with the rationalizing factor root 7 plus root 3 divided by root 7 plus root 3. That is equals to 1 into root 7 it is root 7 plus 1 into root 3 it is root 3. Root 7 plus root 3 divided by, here this denominator, a minus b into a plus b, a square minus b square, that is root 7 whole square minus root 3 whole square. Square and square root are cancelled, square and square root are cancelled. Now what we get it is root 7 plus root 3 divided by 7 minus 3, that is equals to root 7 plus root 3 divided by 7 minus 3 it is 4. Root 7 plus root 3 by 4 we got the result. Now rationalize the second term. 1 divided by root 7 plus root 3. Now what is the rationalization factor of root 7 plus root 3? It is root 7 minus root 3. It is multiplied with root 7 minus root 3, which is equals to 1 into root 7 minus root 3 it is root 7 minus root 3 divided by a plus b into a minus b is equals to a square minus b square, that is root 7 whole square minus root 3 whole square. Square and square root are cancelled. We will get root 7 minus root 3 divided by 7 minus 3, that is equals to root 7 minus root 3 divided by 7 minus 3 is 4. Now we have to add these two. That sum is equals to what we get? That is equals to root 7 plus root 3 divided by 4 plus root 7 minus root 3 divided by 4. That is equals to, take the LCM of the denominators. The denominators are same, therefore the LCM is 4. Just add the numerators. It is root 7 plus root 3 plus root 7 minus root 3. Plus root 3 minus root 3 are cancelled. We get 0. Root 7 plus root 7 is root 1 root 7, 1 root 7 is 2 root 7 by 4 we get. 2 1s are 2, 2 2s are 4. We can cancel because both are rational numbers and their numerators and denominators. So now it is root 7 by 2. Root 7 by 2 is the simplified form of 1 over root 7 plus root 3 minus root 3 plus 1 over root 7 plus root 3. So similarly, here the b bit is square root of 5 plus root 2 divided by root 3 minus root 2 minus root 5 minus root 2 divided by root 3 plus root 2. how do we do this kind of questions? We'll see. Build it. So the rationalizing factor of the first term denominator root 3 minus root 2, it is root 3 plus root 2, and here root 3 plus root 2, for this the rationalizing factor is root 3 minus root 2. Simplify the first term, that is root 5 plus root 2 divided by root 3 minus root 2 is multiplied with what? Root 3 plus root 2. So this is also multiplied with root 3 plus root 2. So what we get? So root 5 into root 3, a into b, ab, 5 into 3 is 15. Root 15 plus into plus, root 5 into root 2, 5 into 2 it is 10. Root 10 again plus root 2. Root 2 into root 3, 2 into 3 it is 6. Root 6 plus root 2 into root 2 it is root 2 whole square divided by the denominators a minus b into a plus b, a square minus b square, that is root 3 whole square minus root 2 whole square. Now simplify this. So here square and square root are cancelled, square and square root are cancelled, square and square root are cancelled. Now what we get? It is root 15 plus root 10 plus root 6 plus 2 divided by 3 minus 2. 3 minus 2 will get 1. So that is root 15 plus root 10 plus root 6 plus 2 divided by 1 we get. Divided by 1. So divided by 1 in the sense what we get when we simplify this? Root 15 plus root 10 plus root 6 plus 2. So that is the simplified form of the first term. Next is second term. Here we have 5 root 5 minus root 2 divided by root 3 minus root 2. So the conjugation. So root 3 plus root 2 here. Root 3 plus root 2. The conjugate or the rationalizing factor of root 3 plus root 2 it is root 3 minus root 2. Root 3 minus root 2. And this is root 3 minus root 2. Simplified. Plus into plus, root 5 into root 3. 5 into 3 is 15. Root 15 plus into minus, it is minus. Root 5 into root 2 it is root 5 into 2. 5 2s are 10. Next, minus into plus, root 2 into root 3 it is root 6. Minus into minus plus, root 2 into root 2 it is root 2 whole square. Root 2 whole square. Root 2 whole square divided by a plus b into a minus b, that is a square minus b square, which is equals to root 3 whole square minus root 2 whole square. Square and square root are cancelled. Here square and square root are cancelled. Now square and square root are cancelled. Now what we get? It is root 15 minus root 10 minus root 6 plus 2 divided by 3 minus 2. 3 minus 2. That is root 15 minus root 10 minus root 6 plus 2 divided by 3 minus 2, it is 1. So when we divide with 1, what we get? The same number, root 15 minus root 10 minus root 6 plus 2. Now we have to simplify these two things. Yes, we have to simplify. Subtract the second number from the first number. That is equals to root 15 plus root 10 plus root 6 minus, that is plus 2 minus the second term, it is root 15 minus root 10 minus root 6 plus 2. So simplify this. Square root of 15 plus square root of 10 plus square root of 6 plus 2 minus into plus minus root 15 minus into minus plus root 10 minus into minus plus root 6 minus into plus minus 2. Now plus 2 minus 2 will be cancelled, get 0, plus root 15 minus root 15 gets cancelled. Now root 10 plus root 10, that is equals to 2 root 10 plus root 6 plus root 6 it is 2 root 6. So take 2 common, then what we get? 2 into root 10 plus root 6. So this is the simplified form of root 5 plus root 2 divided by root 3 minus root 2 minus root 5 minus root 2 divided by root 3 plus 2, root 2. So we will simplify this by using the concept of rationalizing the denominator. Is it clear, children? I hope you understand today's class. Thank you very much.